influence of technology in everyday life rather increased a lot by the last decade. And the IT infrastructure, that is the underlying part of that evolution, facilitates the exchange of things in a secure and reliable manner. Today's world, this technology is touching almost every part of the business. The communication, human relationship, technologies in education, in medicine, transportation, utilities, government, and so on and so forth. And all those technologies, they are basically also, let's say, instantiating more and more into what we are used to say, we are used to call the Internet of Things, the IoT. The main purpose of the IoT is to connect objects to the internet so that the data and insights that were never available before become then enabled. The IoT will then allow those objects to be whether controlled remotely or directly controlled within a network without requiring, a priori, human-human interaction, but more human-computer or even computer-to-computer, which is also called machine-to-machine interaction. We can observe in there home automation, automatic control of lighting, of heating, ventilation, air conditions, security alarm, refrigerators, remote control, your watch, your belt, something you have on yourself, whatever we call wearables, what's in your car, what's in the flight you are going to take back home, I hope safely, and so on. So this integration of the connection, by the way, and the intelligence you put in those elements is more and more increasing. Basically, the Internet of Things can be summarized in those 6 different areas. This is basically anything or any device that can be touched by the phenomenon. Anyone or anybody can have a profit of it. Any service or any business can be run in there through any path or any network, any place or anywhere, anytime, in any different context. So this is the Internet of Things. What we are also, let's say what we are also willing to say, the Internet of everything, everywhere, for everybody. Those elements, they are basically presenting some kind of a hierarchy of needs. Those needs, from their existence, the existence of those elements, their physical need, the need of being powered, the need of being connected, climated, or valued by the entities that are managing it. The security needs, I will come a lot on there after, secure chip, encoding, encrypting, all the element of authentication. The connectivity needs, interface, the communication, networking. The data needs, that are transaction, logs, and diagnostic, and what we are used to call the self-actualization, those what we say smart needs, analytics, logic, learned and predictive behavior that will help also those elements to better interact with our everyday life. To be serving human, of course, this is the main purpose. But this paradigm presents as well some kind of security and privacy issues. The Internet of Things as a, let's say, global internet-based technical architecture that is there to facilitate the exchange and the delivery of goods, service in terms of a global supply chain, has, of course, some impact, some consequence on those security aspects and those privacy aspects for people and entities using it. And some measures will also have to be related to regulation. The need of a regulation to be established to ensuring IoT architecture's resilience is also, of course, an element that is important I say, crucial that we are going to talk about a bit after. Regulation must thus encompass the right to information, provisions, prohibiting or restricting the use of those mechanisms of the IoT, and those rules about IT security regulation, provisions supporting the use of mechanisms of the IoT and research, and the legal challenges to IoT. Talking about security measures, basically, is about talking about four main things. Since you observe that those processes that we are using for interacting with each other in a business or a personal or individual context, let's take it on the business side at the time, because we are talking in there more and more, the high degree of reliability that we are expecting to obtain from those relations is needed. In the literature, the following security and privacy requirements are then usually described. First, resilience to attack. The system needs to be avoiding majoritarily those single points of failure. Let's imagine, for instance, a pacemaker that could be interrupted, would be, of course, worse than ever damage for the victim of such an incident. And should, of course, adjust itself to some node failures in terms of connected object. Data authentication is also another factor that is important to take into consideration, and as a principle, retrieved address and object information must be anyway authenticated. Otherwise, the risk of, let's say, impersonation or abuse of right on those authorization for this object is very, very high. Access control. Information provider must be able to implement access control on the data provided. And finally, the privacy. Client privacy, basically, only the information provider will be able, in that context, to infer from observing the use of the lookup system related to a specific customer, and at least those inferences should be very hard to conduct. In synthesis, I try to summarize those topics that will be touched by the Internet of Things security issues, and we can summarize on top of what I explained before, the question of the authentication, the access control, the privacy, policy enforcement, trust, the question of mobile security, secure middleware, and the question of confidentiality as well. Then we face, out of those questions that are, let's say, organizational and technical, we face also some other, let's say, challenges or issues that are more close to the regulation. Of course, those, let's say, smart objects, to say it short, they need to benefit from the establishment of some kind of an adequate legal framework for the protection of security and the privacy in the IoT. As, let's say, it's a phenomenon giving the rise to the question of the appropriate legal source. Let's take another example. Automatic car, self-driven car. You know that if you use those type of vehicles and at a certain point you don't touch, let's say, anything in the car and the car is self-driving, at a certain point this car bumps into someone or something, who is responsible? There are many legal questions and as well as ethic questions in case of the decision that has to be taken by the system that will be self-driving that are, let's say, arising. Those questions must be, let's say, to some extent, be framed by some kind of regulation that will be encompass all those issues and trying to solve them a certain way, because otherwise this will be the jungle. We have, of course, various regulatory models that could be applicable in that sense. In theory, choice is principally to be made between traditional national regulation, international agreements, and, or, on top of that, self-regulation. So far, the regulatory model is basically, let's say, self-regulated at the time. So we don't have that many obligations and regulation that at the moment are framing the Internet of Things evolution. The principle of that is that let's say the market is to self-define some rules and regulation, best practice, regulation, self-regulation, best practice that at the end of the day will serve the interest of the industry, because nobody wants that my, let's say, self-driven car is killing anybody. And in case it would happen, of course, it wouldn't be very, very nice or very good for my reputation. Of course, the question of the challenge of the regulation is also that in a common global economy, addressing those needs in a very separate way, very isolated way, let's say country per country, will also drive to some discrepancies and some issue. On the other hand, it appears that it will be hardly to arrive to a common consensus or a worldwide regulation on those things, and those regulations governing all the facets of the IoT. And we believe that, moreover, an heterogeneous and differentiated approach is probably to be taken into account. When discussing about it, we should take into consideration, let's say, 4 main axes that we are going to consider in those in that way: globality, verticality, ubiquity, and technicity of the IoT. Globality is based on the fact that goods and service in the IoT context will be globally, let's say, marketed and produced by some players, and they will be globally distributed. The technology is also global in the sense that the same technical process are applied all over the world. So this is standardization. This is the principle of standardization. Consequently, business and trade will be heavily complicated if we had different national laws, national regulation that would be in place, contravening to those standardized principles that drive the industry at the moment. And if the products are available on a global level, the legal system needs also to be, let's say, synchronized with what is proposed. That's the principle of globality. Principle of verticality, it means that the potential durability of the technical environment, in particular, it is important for the life of the IoT that products are lasting long enough to not only use them in the supply chain until the final customer, but also, for example, in the waste management. So you don't just think producing those things, but you think also to, let's say, contributing to encompassing the whole chain that this object and these smart connected things will be used in. For the time being, this requirement is generally not sufficiently met because the production of those type of things is well done, but let's say the life cycle, the whole life cycle of those IoT in terms of what they are, and if we come back to the pyramid, those needs for the object, all the needs are not totally covered during the whole life cycle of those products, and especially not on a regulatory point of view. Then we have the concept of ubiquity, the extent of the environment which is technically considered when we talk about those things. IoT technology could then be used ubiquitously, encompassing persons, timing, plants, or even animals, or any, I was talking about entities, so any entity could be touched and concerned by those type of things. So ubiquity, it's a bit of everything, everywhere, as I presented a bit before. Technicity, to the last end, is an important basis for the development of rules protecting privacy objectives. Several differentiations can be taken into account, namely complexity of the tag. For instance, when you consider RFID, you have those different elements. You have the complexity of the background device that are used. For instance, if you consider a badge reader, or you would need to authenticate with your watch passing inside some ring or something. So the background complexity for the relation between the object and the receiver, the transponder, is also something to consider. And the maximum reading range. If you consider, for instance, a biometric passport or electronic passport, when you pass somewhere and you can put your passport on a reader to be, let's say, authorized to pass through. We have that in some European airport at the moment. No, it's like automatic border, so you are not controlled anymore. You pass, you put your passport into the reader, and then you can move along. That needs to be secured a way that your passport cannot be read by someone like stepping 2 meters of you or even 10 meters of you. It's not a Bluetooth connection between my phone and my watch. It's a connection that needs to be very close, so we protect that relation between one object, my passport, and one receiver, the transponder that is reading the passport at the time. These 4 requirements are then to be taken into account when establishing the legal framework. And let's say they have to be taken into consideration, especially considering binding all together, binding all these entities, those participants, let's say, together within the framework. And resulting from these 4 requirements, the framework to be established has to be global, established, let's say, internationally, by legislators, maybe, and applicable to every object on Earth from its becoming until its destruction. That's the paradigm we would like to observe. Of course, this must also be considered as applicable to every object on Earth from its becoming until its destruction, and this ubiquity needs has to be considered as well and addressed in particular if various objects are put together to form, let's say, a new thing. So different things that are connectable can also form some new entities by being connected together and creating new means, new leverages, new service, whatever. And then the legal framework encompassing one object on its own, let's say a watch, could be, let's say, made obsolete, if you consider that I have some chip under my skin that interacts with my watch. It's not exactly the same, because we are going then to enter into some kind of a new form of service. It's not only my watch, it's not only the chip I have under my skin, this is them working together, providing me some benefit. We hope so, not maleficent things. And then that's really important that we can consider that ubiquity needs to be considered also for all those possibilities. Considering the legal framework, regulation about IoT, basically at the moment, if we consider the relation and the comparison between US and Europe at the time, but it's rather simple on the left. I don't think it's need some more comment on there. Last March, the representative of the White House that has been, let's say, interviewed on there said the FTC was primarily a law enforcement thing and called for wait-and-see approach under the IoT. And so the wait-and-see approach means that they are going especially to rely on one group of interest at the moment, which is called the BTAG. BTAG, it's the Broadband Internet Technology Advisory Group, which is at the moment preparing some kind of, let's say, best practice frameworks for encompassing those type of needs. But basically for the rest, no regulation, except if someone in the room has some additional information from last March about new regulation rising in the US. But on my side, I looked for that up to yesterday evening, and I didn't find anything. On the other hand, it's not because there is something in the right column that it's super duper, but let's say presenting it. European Commission started a review process of the e-privacy regulation, which complements the General Data Protection Regulation, called GDPR, governing the processing of personal data on electronic communication. So it's already that. it's not that complete, it's not that globally considered talking about IoT, but it's a first step. Draft regulation recently published is not fully clear, basically, as it does not specify whether it refers only to machine-to-machine communication containing personal data. If we rely to the GDPR, it's more clear that we go this way, or if it is to be understood, let's say, more generally. I invite you to go and see the European regulation, so the proposal for regulation on privacy and electronic communication on ec.europa.eu. The text of the proposal is freely available for reading. So, once considering that the regulation is not at the moment the total and global answer we could expect, let's give a try and let's give a look at the normative framework we could rely on in order, let's say, to take into consideration what about application and software, connectivity, features, and so on, that will have to be considered in the IoT. First, we have the ISO 15408, which is more known with its sexy name of common criteria. It comes from the late 90s. It touches product and software in terms of security, a bit less privacy, but it evolved. Evaluation mainly on product, and take into consideration the context, the technological context, and the business context. It works by defining some criteria that you need to evaluate whether you respect them or not. Very high cost, because those type of projects are super heavy to put in place. Generally, they touch, let's say, critical application, major product, global element that needs lots of budget and effort in terms of development, or very sensitive, managing very sensitive data, for instance, or for some specific purpose like defense, aerospace, or those type of utility. SSE CMM, which is the maturity model for software security evaluation, comes approximately from the same period, and this evaluation is mainly based on processes. It takes into account the context? No context taken into account, only the process from the beginning to the end. It's kind of a BPMN activity, so you observe how it's supposed to work, you take the entry data, how it is processed, how it is given out, and that's it. Control checksum and all those elements. Some criteria, of course, are defined, so you can evaluate your maturity towards some benchmark and some other result given by some previous evaluation. And the cost is, of course, less than common criteria, because the engagement and the requirements are also less demanding, let's say, from the start point. Then you have the content of some controls that appear in the Appendix A of ISO 27001, which are also some commodity that companies are using at the moment in order to, let's say, encompass the best practice for evaluating software. It comes from the standard of 2005, revised in 2013, as you know. It touches the organization. It doesn't touch the software or the product itself, which is, of course, let's say, one of the weaknesses of a very, very generic standard towards the specificity of evaluating software and, let's say, features and specifications. It evaluates the process and general controls, take into consideration business and legal context, but of course, it needs a complement in order to better evaluate the technological aspects that are underlying. A list of criteria is defined. This is the famous Appendix A, especially the clause that touches the acquisition, development, and maintenance, and the revision of software, as well as the separation of test, development, and maintenance environment. Basically, those clauses touch really closely to those concerns. It has a low cost, but it doesn't answer completely. Then we have a standard in evolution. This standard, it has been, let's say, firstly published the overview and the presentation of this standard has been firstly published in 2011, so some years ago, and that is in the pipe, for instance, in the ISO committee, to be published and released by 2019. I don't pass the ball just for passing the ball, but let me tell you that in that room, and you will find them rather easily after, there are two people editing and co-editing this standard that could, of course, answer all your questions after my presentation. So I will pass the ball to Mr. Luc Poulin and Mr. René Saint-Germain. So thank you for being there. It's a bit of a trap, huh? That standard for application security management is to evaluate the process, the organization, and the application that is developed into a certain context. I'm going to explain a bit later on. It takes into account technological, business, and legal context. This is based on criteria, but also on, let's say, self-declaration. So you define what is in it, and you get, let's say, made compliant, you get audited, for instance, according to those criteria that you define. So you say what you do, and then we, auditors, we come and we say, do you do what you say? Okay, this is kind of that paradigm that is followed. The cost can be variable according to the depth and to the large aspect that you would like to cover, so the wideness of the scope that you would like to cover. But what about the marketplace? For those aspects of security evaluation and the aspect of certification of application. Actual market is estimated around 6.8 billion US dollars. The growth of this market is observed at approximately 10% yearly. 10% of the market is common criteria. So basically on this 6.8 billion, 60, so let's say almost 700 of them, 700 millions, are dedicated to common criteria project at the time being. 90% of this market, it's called, in between auditors, we crack jokes from time to time, shadow evaluation. So those shadow evaluation, these are all initiative, all inspection, evaluation that are done into something else, let's say less demanding or less framed than into the common criteria, but following some or other part of what is required within the common criteria. We have, for instance, an example coming from France, the ANSSI, from French ANSSI, sorry, so Agence Nationale de la Sécurité des Systèmes d'Information, so you know that I'm French speaking, give the certification of first level. So first level security certification, certification de sécurité de premier niveau, which is a certification that is, let's say, less demanding than the common criteria, permitting enterprise to enter into those steps without impacting their budget or their effort or their team of software developers too much. This is one of the way it's supposed to work. When we consider that marketplace, we need also to consider what type of application are considered. If you remember, we talked about the Internet of Everything. So this Internet of Everything can also be, of course, let's say, considered into the cryptography industry, with, for instance, production and diffusion of smart cards, token, ID cards for managing the, I was talking about the biometric passport and so on. So all what as a chip, let's say, in terms of that. SCADA, so industrial systems, robotics, or M2M systems, the telecommunication systems as well, the Internet of Things as such, let's say the commercial Internet of Things, like those wearables, those elements like self-driven car, blah, 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 web platforms for, let's say, classic application, and also the mobile application. So basically those 6 domains are heavily impacted by this type of evaluation and certification, and they have evaluation and certification need, by the way. For software security, we have also to consider what sectors are, let's say, demanding the most for those type of evaluation and certification, and basically without any surprise, bank and insurance sector, which is, let's say, very compliance-based, is asking the most still up to now for those type of evaluation, but also we observe more and more evolution in telecommunication, defense and aerospace. I was telling you, public sector as well, lotteries and gaming, e-health, utilities, or even in more generally considered the digital economy. So, as I told you, common criteria in such addressing those needs is considered as a premium market. The average cost of a certification, according to the common criteria, is around $1 million US. The cost of annual maintenance of those projects is 1/3, more or less, for the initial effort that the enterprise paid. So here, around $300K. And this is a market of, let's say, around $600 and $700 million. I presented, I won't go too much into deep in there, but you have the categories of projects that are covered at the moment by common criteria and the amount of products that are by now certified according to the common criteria, let's say type per type. I guess the presentation will be given after, so you will have time to read it like at your ease. So there is a kind of a market opportunity for proposing, let's say, something else than no regulation and very expensive common criteria procedures and evaluation. Because we said, and this is more than a statement, this is an observation of the market, the premium market being 10%, we have the security application under no actual certification free for 90% up to now. Considering that there is a space for, let's say, certifying according to some integrated way, which is a statement that notably PECB is putting on the table for a while, we find interesting to observe the possibilities of certifying according to 27034, because it could be kind of a, let's say, I do my Steve Jobs just once in a row, it's a revolution. Risk-based approach and evaluation based on the context of the usage of an application. Self-declaration of the application security control to certify. I'm going to explain a bit later on. Alternative that is less expensive at the end of the day than common criteria. We'll also explain why. Can certify application and organization. So the integration, the vertical integration of application security can be considered not only per product, per program, per application, but also in the context in which those elements are working together. And the standard is supported by major editors, like Microsoft, for instance, or EMC, or even SAP. So those major editors recognize, like let's say de facto, that this standard can really serve the need of the software industry in terms of improving the way we secure the environment, development, the full cycle of software. Not only the development, by the way, but also all the life cycle up to the end of life of this software. So, just a few words about the standard so you know what about, because this is not one single standard, but 7 parts of the same standard. The first part, part 1, overview and concept, has been published in 2011 and introduces the standard in such, presenting the different elements that constitute, let's say, the backbone of the standard. Part 2 takes into detail, to detail about what we call the organization normative framework, which is the observance of, let's say, the context, organizational context and processes that are encompassed into the initiative of making something certified, which is part of the result of some activities. So organization normative framework encompasses and touches very closely to 27001, which it is integrated with rather easily. Application security management process defines the rules that have to be followed to securely manage an application from, I do it for you, from its creation up to its final disposal through the entire cycle, all the steps that have to be considered in the management. Not only in SDLC, not only secure coding practice, which are very, very at the origin of the process, but also when using the application. So users playing with using the application can also be considered in such a management process, which is quite new. Common criteria doesn't touch that question so far very much. Application security validation, what criteria we are going to stick to and what criteria we are going to, let's say, observe as well as to obey to in order to validate the level of security, the level of trust of the application. Some boring element about protocols, application security control, and data structure, but these are, of course, really useful in order to be able to validate that these initiatives are taken the right way. Protocols and application security controls, data structure, and XML schemas must also be considered in the part 5.1. Part 6 is our case studies, and then Luc and René could explain you also how they developed that part, because it's also interesting to put things into reference, into context, so to better understand what about, what's the interest, what's the leverage of putting in place such a standard. And application security, assurance prediction, which is kind of a magical thing that we have put in place in order to, let's say, self-validate some version of the application. I will explain, let's say, off the record, because we are running out of time for the presentation, but off the record, if you are interested, I will explain you, and we will do it together with Luc, how self-prediction can help better leveraging security in between versions of application. Isn't it, Luc? So, of course, ISO 27034 and all that frame, those 7 parts will be encompassed into the guidance, industry or sectorial guidance, or thematic, in that case, guidance, supporting ISO 27001 and ISO 27002. So first, we support 27002 in the sense of guidance and controls, measures. And we support also, let's say, the ISMS. So an organization having an ISMS and being, let's say, certified for the ISMS can also take some benefit from relying on those aspects that are proposed into the different part of ISO 27034. And we finally present you, let's say, very quickly, because we are really running out of time, but it will be our pleasure to discuss that again with you. Let's say, the application security management process, as it should be considered globally and, let's say, consistently from the beginning to the end by the organization. So, starting from the identification of the application requirement and its environment, we are setting an application context, some requirement and specification. We assess the application security risk that will determine one first level of targeted level of trust, which is the level of trust that we would like to get to. This is the will. Third step, creating and maintaining the application normative framework, which will encompass those needs and the answer to the requirement of that the company has been set for managing the application. It provides a first documented and published ANF, realizing and operating the application. And for that being efficient, this realization of on operating the application will provide project artifacts that will be used to identify further need in the cycle of evolution, which is a PDCA basically, which is based on the same approach as the 27001. And it will also provide some implementation requirement for what we call application security control. Those application security control are meant to verify the security of the application and provide an actual level of trust for the application. Comparing the targeted level of trust with the actual level of trust will give you some good indication on what has to be done, what discrepancies you have to mitigate, to diminish in order to get more compliant with what you expect to be done by your application development. This is basically the security management process, which has also a feedback generated. That's a PDCA, by the way. And that feedback will also feed the organization management process by corrective actions and a way of dealing better with those problems, issues, and discrepancies that you have been meeting during the whole first bunch of tests that you have been doing. But let's say, if you are interested, that's for us, and I will conclude on there, that's for us as a PECB and as a certification body, one of the very smart and interesting way to address the future and the further challenge of the Internet of Things, software development, evaluation in the coming years. So thank you very much for that.